Hello everyone. So today we are going to discuss the problem number B of div 3 of round 1103. Okay. So the problem name is Tatar TV Show. Okay. So what is in the problem? In the problem we have given a string, binary string and an integer k, and we can choose, we can invert the bits, and at the end we have to check that we can able to make the whole binary string 0 or not. Let me explain the problem in a much better way. If I take this test case, okay, suppose we have given a string like this. Okay, what is given in the question? We have given a string like this, and we have given a k. Suppose here the k is here is 2, and what we have to do, we can choose any I and convert I and I plus k bits. Means we can invert the bits of I and I plus k. Suppose if I choose here I as 0, then we can invert the bits of position 0 and 0 plus k. 0 plus k means 2. We can invert the bits 0 and 2 position, then our string 0 and 0 becomes, we can invert the bits at position 0, it will become 0, then there is again 0, and in the 2 we can 0 0, and that's how we can convert by the whole string into 0 by choosing the bit I barabar 0. And according to question, we can take any number, how many times we can want. We can choose the I and just invert the I and I plus k bits, and our goal is to check that whether we can able to make the whole binary string 0 or not. Okay. Let me take other examples. Let me take another example, like suppose we have given a binary string like 11000101. Okay, suppose this is the binary string, and there is k as given as suppose as 3. Okay, and we can perform operation any number of times, and the operation is that choose a I and invert the bits at position I and I plus k, and goal is to check whether we can convert the whole binary string equal to 0 or not. So we have to check that we can do this or not. So what is the first idea that comes in our mind? Like we can take a start from I as 0, we can start from I barabar 0 and invert the bits at position I and I plus k, like here 0 and 0 plus 3. We can this much convert the bits, and we can convert the bits, and then we can go for I is equal to 1, I is equal to 1, and then again try to invert the bits at I and I plus k. So this is the first idea that comes in our mind. And while inverting the bits, we are not like required to choose every index. The index is on our preference, we can take or not take, it's up to us. Okay, so whenever we choose any index, we can go greedily, like if there is 1, then we can invert the I plus k. If there is already 0, we will not invert the position and I plus k. So for any position for any index, okay, what are the possibilities for any index? What are the possibilities of I and I plus k? There I can see there are 4 possibilities. Like if I make a I and I plus k, okay, I can be what? I can be like our I can be 0 and or 1. Okay, And what about I plus k? If I talk about I plus k, okay, so according to I plus k, I can be also 0 1. So if I talk about the pair of I and I plus k, we can get 4 possibilities, like I can be 0 and I plus k also 0, or it will be 0, I get that 1, and it will be 1, I get I plus k for 0, and the last I and I plus k both are 0, both are 1, sorry. So for any index I, there are 4 possibilities of I and I plus k, and our goal is to make the whole binary string to 0. So what I will do is I can go for all indexes and check for I and I plus k. So if I already get the both 0 and 0 in both positions, we will not touch that, we will not invert that, or we will not choose that index for our operation. We just leave this because our goal is to minimize. Okay, what if we get a I as 0 and I plus k as 1? So as we are traversing from I to n, 0 to n, and we first get 0 and then further we get 1. So I think we should not touch this also, because our goal is to make everything 0. So as we firstly get the 0 and then further we are going to get the 1, then further one we can anyhow make that 0 when we go at that particular position. So I think for this condition we should also leave this. That's it. But what if there is 1 0? Okay, so we are traversing from 0 to n, the last position of the string, and we are currently getting a 1. And our goal is to make everything is 0. So it seems that we should make this, or consider this index into our operation, because our goal is to make this 1 to 0. So we have to consider this. Consider it. Okay. So what if we have 1 and both I and I plus k? Then definitely we have to consider this index. So we will iterate in whole string. We check for all I and I plus k. If upper two conditions satisfied, then we will not take that index, and if last two conditions we can see at the particular index, then we will invert that. Okay, and finally after doing the operation at all indexes, we will check in our string that is there anyone. If we got anyone, that means we are not able to convert the whole binary string into the 0. So that's the whole logic we can use in this question. So let's try to code it out. Okay, so let me first make it comment out, and let's try to code this out, the question. So if I talk about the input, so the first line contains, so let me first make the boilerplate code. It's std c++ .h using, let me zoom in first, using namespace std. This is the main function. Okay, so we have something like this, the test cases, and you can take this as input, and we can simply do this and just call a function that is just solve for all test cases, and we can make this as this. And what in the second, the first line of each test case contains two integers n and k, that is the size and the k. So there will be an n, a k, and we can take the input for n and k. And in the second line we have a binary string as of length n. We can take a string as s and take the input. That's it. And we have to check the operations. So This is the all input we have to care about. Now it's time to perform all logic. So this is the string s, and we have to check that we can convert this string s into all zero on. So what we can do, we can simply traverse till 1, and we have to go for I plus k. So I think we should go till n minus k only. And there is I plus plus, and there is si. If I consider this condition in which both are 1, okay, if both are 1, we have to invert them all. We can just make this si as 0, and this si plus k as also 0. And what if, and the second condition, do you remember, the second was what? 1 and 0, which we have to consider. So if this is 1 and the I plus k is 0, so we can simply, we have to consider this si will become 0 and si plus k will become 1. That's it for one condition. And at the end we have to check for any in the whole string. If I get any one as 1, that means we are not able to convert this into the required. And at the end, if we have converted this, we can just return from here, okay. But if not that case, we have to see out what, that yes, we have converted the one given minus string into all zeros. That's it. Let's test it out. Let's try to run the code, and it is chilla. Yeah, yes, no, yes, no, yes, no, yes, no. So that's how we can solve this problem. Let's meet in another problem. Bye bye.